So I'm going to show you the lab materials for week 1. So you can go to the module 1 roadmap, and from there you can go to the computing intro to R, and then you will see the lab for week 1. The first thing you should probably do is to download all of these materials. You don't have to download this one, but yeah, let's just go ahead and download all of the files that you have here. It is important to download everything from here to one single folder, so that when you run the R markdown, then everything can be found in one single folder. And also you have this lab 1 exercise. I will briefly discuss about this exercise as well. Create a folder called data, move this here, open this, and first thing you can try is to run the knitting to HTML. And if you have all of the packages installed, it should run smoothly. And if you have some packages that are not installed properly, then you can install them from here. Say for example, if you have your a package that is not installed, such as ggplot2, you can simply write ggplot2 and then you just press install to install that package. Alright, so there are two ways we can use this type of R markdown file. One is basically using this document as a live document. So for example, I'm using R as a calculator here. I'm adding 1 and 1, and I can simply press this blue button and it will show the result of that calculation. The second way I can use is that when I ran this lab1 RMD, it created a HTML file, and this is the lab1 RMD. And you can basically see all of the outputs that are being created if you write all of the functions properly. You will see all of the functions as well as all of the commands or syntax, and all of the outputs all together in a nice fashion. So I will go through this lab today with this particular RMD file. So at the beginning, I'm just describing some of the R syntax, and you should be familiar with R by now because you have all taken SPPH 400 and 500, and in that particular course I know that R is being used to describe some of the analysis content. So in this particular lab, what I will do, I will try to review some of the materials, and then I will switch to some of the basic data analysis functions and describe them. So as you know, in R we can also assign a value to a variable. Say for example x is a variable and I'm assigning 2 here. So when I run this, I get, after printing the value of x, I get the value of 2 because I have assigned the value 2 here. I can also create another variable based on an existing variable. Basically you can see you have created a variable, and this, if you print that variable, you will see the output of that. You can do the plotting of a function using a curve function, where I'm basically plotting the x square, and the value of x should be begin from 1 to 10. So if you just run it, you will see the whole plot in here within your RMD file. And if you are not familiar with some of the arguments of this function, and if you want to know what else can be done using this function, you can simply type in question mark and then the name of the function. So in this case the name of the function is curve. So you just can see from and to are 2 different arguments, but there are many other arguments you can use, and in this help file it basically describes all of the arguments in detail, and you can add various arguments to describe or call various aspects of this function. If you do not know what specific function you are looking for, or you know that you want to plot a box plot, but you do not necessarily know what is the function you should call within R to draw that box plot. So in that case you just write double question mark and then the name of the function. So if you do something like that, R will do a quick search and try to find out all the different functions that you can use to draw box plots, right? So from the car package you have a box plot function. From E1071 package you have another function. In ggplot you have a function. In the graphics you have box plot function. Basically these are the functions, function links, and you can navigate from here as well. Alright, so you probably already know that in R, when you assign a variable, that variable can be a scalar variable containing only one value, or it can be a vector. That means it can contain multiple variables, multiple values in that variable. So in this case what I'm trying to do is I'm trying to create a vector, and the values of the vectors are in here, and I just write the values and then I use the C function to include those and assign those in the X variable, and I can print that X variable. Similarly I can use the 1 to 10 type of function to assign the same numbers in X, or you can use the SEQ or the sequence function to assign all of these. So if you simply print all of these 3 different X, you will see all of the numbers are the same, and this can be happening in a sequence. Say for example, if you are defining this in from X to 5, and then if you define it from X to 7, and then if you define from 1 to 10, and you see you are assigning X all in all of these cases, but in sequence you can see all of these are being printed. So this is basically an output of the first X, this is basically the output of the second X, and this is basically the output of the third X. Alright, so I have already described curve is a way to plot. There is another function called plot, and you can use that plot function to draw the plot. You can use some other functions, arguments within the plot function. So for example, if you look up the plot, I think think this is in the base package. Yes, and you can simply write a type equals L to redraw the plot, but using a line in this case. You can call various functions within R. So for example, I'm calling the exponentiation function here. In our case, the x was from 1 to 10, and this is the exponentiation of those. You can call the R norm function to do some random sampling from the normal distribution, and you can specify the mean and the standard deviations. And if you use this function again, notice that I'm using the same command, but I'm getting different numbers. So that is because it is supposed to be a random sample. But if you are trying to reproduce your results, say for example, if you print out something and you want to show me or some of your other collaborators the same numbers, you can use the seed function, set seed, and then you get a specific set of number, and if you get provide that seed, when you run the R norm function again, you can get the same numbers as long as you have the same seeds. So for example, if you use seed equals 11 and seed equals 12, in that case, if you run both of them, you will see the numbers are different. But if you are using the same seeds, you will see now the numbers are the same. Alright, so in terms of assigning values to a vector, you can assign numeric values as we have seen earlier for the variable x, but you can do the same for the character values. You can assign the character values to a vector, and you can see the way I have written the uppercase and lowercase is important. I wrote BLU in uppercases and E in lowercase, and you'll see this will be saved in the same way that you write. And you can check what type of variable you are using. So for example, our x variable was a numeric variable and this z variable is a character variable, and you can simply check what type of variable by checking the mode. So see, x is a numeric variable and z is a character variable. You are probably already familiar with matrix. So for example, remember what was our x? Our x was from 1 to 10, and in here what I'm trying to do is I'm trying to create a matrix out of those values where I want 5 rows and 2 columns, and I want the numbers to be by row. So you see, I have 5 rows and 2 columns, and the number are in by rows. That means it will fill the first row and then the second row and the third row and so on. You can also do the same by column by setting by row equals false, and you can see you still have 5 rows and 2 columns, but now the numbers are not by row. That means the numbers are by column here. Alright, so now that you have these two matrices, matrix 1 and matrix 2, you can merge those two matrices. So this was your matrix 1 and this is your matrix 2. You are simply merging them. You can append them as well. And to do that, we are simply using two different functions. For merging, I'm using the cbind. For appending, I'm using the rbind function. So other than matrix, there is something else that is called list, that is very useful when you are working with R. So list is a object that can contain other objects that are of different kinds. So for example, in this case I have two different matrices, and I do not want to combine or append them, all I want is to save both of these in a list, but I don't want to combine them in any way. So when you use this list function to save them in the list 1, you can see within the list 1 there is the first list and this is the second list, and it is saving those two matrices separately. So the first element is your matrix 1, the second element is your matrix 2. You can also include more than two type of elements. There are many other type of elements that you can include. Remember, this is the list 1 that we just created, and within that list we have two matrices. And then we have this x, which was a numeric variable, and then we have this y, which was a particular scalar, and we have this z, which is the character variable. So all of these things are being saved in this particular list 2. And also notice the layers. So see, this is the first layer, and within that layer you have these two matrices saved in a list. So this is in total a list itself. And then you have the second layer where you have this x vector, which is numeric, and then you have this third layer where you have this scalar variable, and you have this fourth layer where you have this character variable or object. Alright, so here you can see I have a x variable or object that includes 1, 2, 3, 4, and as you remember, I have this this z variable that includes this character vector. And when I combine these two, one is numeric and one is character, what will end up happening is that I will get a new matrix out of combining them. But when I check the mode of them, you can see this is basically converting everything to a character. See, you have quote marks around this 1, 2, 3, 4. That means what R is doing when you are using cbind on the numeric and character vectors, it is converting them to character vectors and including them in the matrix. So generally that matrix will be turned into a character matrix. So if you want to avoid that, if you want to keep the numerics as numeric and character as character, you can use something called data frame. And to create a data frame, the function is data frame function, and you can simply add them. So when I print the df, you can see the output by clicking here. You can see x is 1, 2, 3, 4 and z is all of the colors. And when I check the mode of the df, you can see this is a this is calling it as a list. The mode of the data frame is a list format. Alright, so now we are talking about extracting specific elements of a data frame. Say for example, when I'm trying to extract the first row and the first columns element, it was 1. If I want to extract the first column, I write it like this, where this is the column indicator after the comma. When I run it, you can see all of the first column elements. If I want to see the first row elements, it will be 1 and then the comma and nothing else, and that will give me the first row. If I want to assign a not available value or a missing value in this first element or this first element, I can simply assign a value within the first element, and when you print that, you can see the first value is not available or missing value, and rest of them are as it was defined earlier. And notice that I have these names x and z. If you want to give a bit more informative names, you can change the names by using the names function, and that will assign new names. Whatever names you assign in whatever characters or uppercase or lowercase, it will assign exactly the same way, the way you have defined your names. And also you can check the row numbers and the column numbers by the end row and end column function. In here I particularly have 4 rows and 2 columns,